Okay, good morning. It is Monday, and there's chat messages already. Let me pull that up. Yeah, obligatory Knicks gang. What up, Alexandra? Did I go to bed at 4 one day? Probably. You need a better sleep schedule. Yes. I mean, always. It's the best it's actually ever been in my life, but I do occasionally still have some 4 a.m. days. So yeah. It used to be that 4 a.m. was an everyday thing. Now it's a rare occasion. So this is actually a, personal best timeline for me right now. But yeah, evergreen. James needs a better sleep schedule is that. But yeah, I hope everyone had a good weekend. I'm trying to think. What's happened since Friday? Let's just look at the repo and figure out what's happened since Friday. Alexandra's been working on that network testing debugging harness. It's looking very, very cool. We've been chatting about that a bit in chat. There was also someone was trying out. They're working towards a system where they have an ESP32C3 and an NRF52840 on the same board, and they were initially testing it using the NRF52 as a serial device and using Edge, using an Edge device on the PC. We can go look at that because it's pretty cool. So they got their NRF52840, which is it's not using the USB, it's using the serial port functionality. So it's using the embedded I/O async adapter. And just kind of a simple hello world. I think they were trying to repro a bug for me, which I appreciate them giving me a repo. So I was able to get it working immediately using the Ergot or the log router serial application, which told me that their 52840 code was working correctly. And so there was something up with their PC implementation, and what they had done is they had kind of wrapped, I think it was Tokyo Serial, maybe some kind of serial. Yeah, Tokyo Serial. They'd wrapped Tokyo Serial in an embedded IO sync adapter, which is pretty cool. And then we're using a direct edge for this as well. So actually a lot like the RP2040 serial pair example. But they were getting problems where the packets weren't getting routed at all. And what it ended up being was that what was it? Even though the direct edge has like a controller and a target configuration, the controller it was still acting in the same way as a target, where it goes, okay, I'm going to wait until someone gives me a packet so I know what my address is. But if both the controller and the target were doing that, then neither of them were going to work. So we basically had this, where both devices were kind of like patiently waiting for the other one to tell them what their address was, which means no one was routing packets to each other because they went, I don't have an address, I can't speak over the network. So the fix was I added a new constructor for the controller side that just says, my address is 11. Cool. I don't wait. I just have that address. And that way, when it starts talking to this device, it goes, your address 12. And it goes, okay. And then all of a sudden it starts talking again. And this is kind of what when we're using the serial port version of this, that's what this does. It goes, okay, every interface I open up, I'm 11 or 21 or 2 or 31. And I'll assign this one automatically to 12, 22, 32, and things like that. So I probably now should go back and look at the serial pair example, because it had sort of like a special version of Direct Edge, where it had its own. This one's interesting because we actually define an interface and a profile in this project. Because this one uses either wait for idle or wait for line break or something as framing. So instead of doing Cobb's framing, it does some out-of-band signaling for deciding where the end of a frame is, which is why this worked and the other one doesn't, because when we're running if we're a controller, then we hard code what our address is. So basically I just applied the same trick to this. So I was going to see if we could refactor this away, but I just remembered we're using read until idle or read until break. So probably can't refactor this further, but there might still be room to not duplicate this. But the actual change is now DirectEdge has a new... The RX worker specifically for it has a new target and a new controller constructor, and there's no more just new. And when we are a controller, we just hardcode our interface state as active with the net ID of 1 and the central node ID, which is 1. If we're not a controller and we're a target, then we go, I'm inactive until I get a packet. And then there's a handler in process frame where it says, like, if we get a packet that has like a real network ID and node ID for us, then we'll take that and we'll become that node, because we assume that if someone's sending us packets, that must be us as a destination. What's that, bro? Shukratov, welcome. Ergot is a networking library. My repo is James Munn's Ergot. We got some information here. But yeah, it's a messaging library for talking between devices and controllers and stuff. So, don't know how you found the stream, but welcome. I'm working on this. But yeah, I think that's the big stuff that has happened since Friday. Yeah, I'm flying out this week, Thursday, so we will probably have a Wednesday stream, at least the morning stream, maybe not the evening stream if I'm running around with my head on fire. But yeah, there won't be a Friday stream this week, and then there probably won't be any streams next week. And then let me look up... Let's see. Yeah, there might be a stream on Friday. We'll see. But I would expect streams to probably start back up the week of the 22nd. So next week. So probably no stream on Friday the 12th. Probably no streams this time. And then probably starting back up on the week after the 22nd. I'll be back to streaming. But yeah. Work is still ongoing. The next stuff up is still... I have something I can talk about. The next stuff up is still like figuring out bridging and routing. We're fairly close, so the next step up is to make like a stud application that can do our indirect routing. So this kind of setup where, you have to route across multiple hops and stuff like that. So that's still next up. One of the things that I was thinking about over the weekend, and I don't have an answer for this, so I'm putting it out for the chat if people have good ideas for this. So right now, the way this is going to work is we have our seed router running on the PC. So when this microcontroller attaches over USB, it goes, hey, I get an address for my connection here. So like, the PC will just start talking to me, and I'll figure out my address of this interface when someone starts talking to me. Once this interface is up, then I'll turn around and go, hey, I need a network ID assignment for this interface. It'll ask the PC. The PC will say, cool, here's your net ID. And it'll go, cool, this net ID is now this number, and I'll maintain that assignment. And then if we need to repeat that down the depth, we can do that. So that should work. But there's one interesting thing that Ergot devices are likely to do that AppleTalk never had to deal with, and that is devices that move. So what happens if we start up without USB connected? we don't want to wait until USB is connected to talk to other microcontrollers that are on the same circuit board as us. So we'll need this microcontroller to be a seed router for this and start like activating these connections and, getting the rest of the network going. So it'll go, okay, cool, I'm in charge, so I'm going to assign net IDs and stuff like that. And it will do that. But then what happens when we plug in over USB? Because let's say we made this interface 1 and this interface 2 and so on and so forth, and we get plugged in here and we get assigned some net ID, and 1 and 2 are already taken on this network. And I don't have a great idea of how do we handle that transition. And then similarly, if, okay, we've done something and the whole network is happy again now, and we disconnect USB, what do we do now? Does this take over being the boss? Does it reassign everything again? Does it say, okay, well, I remembered what the whole routing table is, so we'll just keep that, and I just will reject any like upstream packets now? And yeah, so basically, how is that going to work? And the answer is I don't know yet. It's a thing that needs to be designed. The simplest answer that I can think of is adding some kind of network level packet that's basically just like a hard reset to everyone that says like, hey, whatever you think no, you don't, and basically start over. Like, you don't have to do a physical reboot, like you don't have to reboot the chip, but essentially like a net stack reset where you forget any routes that you have, you set all your interfaces to inactive and stuff like that, and that way this one can go, oops, I've lost my connection to the seed router. This is like a crazy event time, so I'm just going to fire a broadcast packet down this way that says, oh no, everyone go back to networking like we started, and then reinitialize everything with the microcontroller as the boss, which I think will probably work. It will probably cause hiccups, like network hiccups, where everything on the network has to kind of reset a little bit, which I don't love. It also means that applications need to like sort of be aware of this, because if they say like, oh, I've done discovery and I decided that the log sync exists at this address, like address 22 or something like that, I need to know that if one of these network upsets happen, that I need to like forget that, and I need to ask again because that's timed out or something like that. So yeah, this is one of those unfortunate cases where I can't super go into the Apple Talk history, because seed routers always were required to exist. There was required to be one seed router on the entire network, and in 1990 computers didn't really move or change their topology very often. Like, we might change the weight, like there might be we've decided this link is faster now and we'll route that direction, but I don't think there was anything for like, there were no laptops at the time, so you wouldn't be like switching between Ethernet and Wi-Fi, for example. So I've got to figure that out. I don't have a good answer for that. That's worrying, but it's one of those problems that I'll hold on to. Like, I'll probably do the dumbest thing that I can for a while, and see how long I can get away with that, and then try and think of something smarter. So if you're watching in the chat and you have an idea for something that might work, hit me up. This is an unsolved problem. I'll probably write up a discussion for it. Yeah. Another thought that I had would be something kind of like NAT, like NAT, where the microcontroller here knows that there's like a mapping of like, okay, everyone downstream of me thinks that they're address 1, 2, and 3, but when I forward their packets onto the PC, I lie and say they're 23, 24, 25, or something like that. I think that could be a possibility, but that would also be a fair amount of work, and I don't love it. There's also a possibility that we have some concept of like a local network where this one can't forward packets up here, but I also really don't like that idea. So yeah, I don't know. If someone has prior art of some other protocol or something that handles this well, or an idea for some kind of thing that we can add, I'm interested, because I don't, like I said, this is I don't have an answer for this. So, yeah, I'll keep working on routing. Yeah, Nat is already evil, IRL. Yeah, but the unfortunate thing is that we don't have a concept of something like CIDR routing like TCP/IP does, where you might have like, a local network where you've got 192.168 existing in here, and there might be another 192.168 somewhere on the network, but it's specifically a local area, but that sort of requires natting at that point. Like if we have a local interface and we have to do that remapping, we essentially have to do natting or something like natting at that point. And Ergot really says that we don't do that. Like, so far the answer has been don't. Like, you have to have everything unique on the bus. But, yeah, I don't know how to solve that between those two ways. So the only other thing that I can think of is, like, do a network level reset where maybe we even, like, get everyone to drop all their sockets and stuff like that, but then all the sockets need to be failable of like, oh, there has been a fatal, we've detached all the sockets, your socket will not work anymore. And that's a problem for some interfaces. Like, it's probably a mistake right now, but in terms of when we have sockets and topic sockets, and let's just go to whatever stack fac. And when you have a receiver handle, for example, if you call receive, there's no result here. You just get a message back. And so if we do have the possibility to like do a system-wide reset, we might want to surface this and like close all the ports, or close all the sockets rather. Just to signify to the user, like, hey, things have changed. That being said, we don't necessarily have to change the sockets, but I'm worried about, because, like, we already have cases in services where, like, the socket query stuff, or, like, the seed router request, we do a discovery for this, and then we remember what that address is, and then we keep talking to it, and we need some way to like break us out of that, or make it clear to the user, hey, something fundamental has changed. Just because you've gotten an address, don't assume that you can hold on to that, because what was 22, network address 2 when you started might be different after we've changed our network topology. So yeah, I don't know, things to think about. Things that we will, good problems to have. It's been neat lately because Ergot's again sort of getting to the place where you can just make changes and like add features and it goes fairly smoothly, which it wasn't for a while because there's a lot of refactoring and cleaning things up. But I think we're in a good space again, which is good because if I'm not working on it as actively, then we want to be able to make little wins like this. But yeah, I think that's all on that. The other thing, OK Zorung was talking about maybe having something that handles fragmentation. Right now, USB handles fragmentation, for example, but we don't have anything that's portable that handles fragmentation. So if we end up having like CAN bus or BLE or I2C, where you're likely to want to send bigger frames than your network link can allow, like BLE has something like 140 byte limit for frames. So if you want to send a 500 byte frame, you need to break that up into chunks and then send that and reassemble it on the other side. So we might want something portable for that, but I've just said, yeah, I'm open to a PR for that if there's a way that we could do that. So, okay, Sorung, if, okay, H Sun Rog. Okay, I'm pronouncing it wrong. But Yeah, if you or someone else is interested in that, I think it'd be cool to break that up. We might be able to steal stuff from the USB impl and then, just make it an adapter of some kind, which would be neat. Okay. And there's some chat in the main embassy room. About performance of postcard benchmarking fairly well, but there's another library called Bitcode, which I have noticed is a bit faster than postcard. And there's some benchmarks here that say like Bincode is a little bit faster and that Bitcode is a little bit faster, quite a bit faster actually. And I'm surprised because postcard's really not doing a whole lot. So them getting like, I could live with 0.3x faster because that's, I don't know, maybe just noise, but Bitcode being quite a bit faster, I don't love. I want postcard to be faster. So, so far, Xenix has had some notes about Bitcode is much more aggressive with doing inline always, whereas in postcard, I just do inline and let the optimizer decide whether it wants to inline or not, because I don't want to bloat up code, particularly for embedded systems. That's a problem. Whereas on the desktop, it might make more sense to inline everything because it might play better with cache, and you don't really care about the increased code size. Or it's really that like the duplication, you don't care about duplication because if you have like, serialize a string repeated 50 times because it's been inlined everywhere, that might be faster on a desktop because you don't have to like jump to a function and have a cache miss, even though the total code size is larger and things like that. So I don't know. I'm probably not going to immediately do anything about that, but I have told Xenix that if he does poke around and see if this does make postcard faster, then I'm maybe okay with having like here, let me copy and paste what I had of like doing something like this where we if you've activated the inline aggressive feature, it uses inline always, and if you haven't, then it just uses inline. And this is gross to put all over the code base, in my opinion, but if it gets us like a 20 or 30% speed increase, it's probably worth it. So I could live with that. But yeah, let's go ahead and say last call for questions in chat or saying hello or things like that, and I'll probably wrap up shortly and do some other work stuff. I'm probably not going to work on Ergot immediately, but we'll see if I can get some stuff done today. But yeah, if there are any questions, let me know. Otherwise, I will take a sip of my water and wrap up here in a second. Okay, I'm not seeing any more questions, so I hope you all have a wonderful week and a good rest of your Monday. I will be back online today at 8 p.m., so about 8.5 hours from now, and we'll see how the day went. So have a lovely day, and I will see you all later. Thank you, everyone.